Welcome to the Deep Dive. We're here to plunge headfirst into the ideas and insights you share with us. And today, wow, we're tackling a topic that's just everywhere, isn't it? Artificial intelligence, you can't miss it. Headlines, boardrooms, just everyday chatter. Especially the buzz around generative AI, it really feels like this huge wave of excitement. And honestly, for good reason, the capabilities are pretty astonishing. But here's the thing. It makes you wonder, is this the only AI we should be paying attention to? Or is there maybe a bigger picture, particularly in the industrial world?
That's such a critical question right now. And, the source we're digging into today, Colin Masson's article, tackles this directly. Yes, the excitement around generative AI, totally warranted. It is revolutionary in many ways. But there's a genuine risk, and Masson calls it a kind of AI amnesia.
AI amnesia. That sounds intriguing. What does he mean by that?
Well, it's this tendency in our rush towards the new shiny thing, generative AI. We're sort of forgetting about the powerful proven AI tools that have been doing heavy lifting in industry for, well, decades.
Ah, okay. So AI isn't really new for industry then?
Not at all. These aren't just, lab experiments. They're workhorses. Optimizing processes, predicting when machines might fail, ensuring quality. This has been happening quietly, effectively for a long, long time. It's a history we can't afford to ignore if we want to be smart about using AI now.
Right. Context is everything. So our mission today, our deep dive, is all about unpacking Colin Masson's IndustryWeek article. Smart AI use is about understanding the tools, then using them strategically. We're going to explore this full industrial AI toolbox, right? And show why real success isn't about just swapping old for new. It's about understanding all the tools, all the instruments in the orchestra, like Masson says, not just the flashy new trumpet that just showed up. We get into what these tools are, what they do, and crucially, how to use them strategically without falling into common traps. Okay, section 1. This AI amnesia problem. Let's start with the undeniable impact of generative AI. The article acknowledges its ability to create novel content and interact in natural language is genuinely transformative. It feels different. Why has this specific capability sparked such incredible excitement?
It really is a genuine breakthrough, especially in how we interact with computers and generate content dynamically. Think about older AI systems. Powerful, yes, but often needed very specific, structured input. You fed them data in a rigid format. The output wasn't always, let's say, user-friendly, maybe complex dashboards, or you needed specific commands.
Right, you had to speak computer to it, essentially.
Exactly. Generative AI, especially LLMs, flips that. You can use everyday language. It feels more like talking with something, not just at something. That accessibility is huge. But it's also the creation part. It doesn't just understand, it produces. Text, code, images. Ask it to draft an email, summarize a report, maybe even suggest some code. That's the revolutionary bit for many people. It feels like a collaborator.
Yeah, that accessibility, like you said, it feels like the computer learned to speak human. But then right after praising this, the article hits us with AI amnesia. It's such a striking phrase. What does it really signify in an industrial tech context? Why is it a potential pitfall?
It signifies this narrative gap. The public conversation, sometimes even inside companies, kind of acts like AI just popped into existence around 2023 with things like ChatGPT. But Colin Masson, from his work at ARC Advisory Group, he stresses AI is not new to industry. It's just evolved. For years, they've used the term industrial AI very deliberately.
To cover more ground than just the latest thing.
Precisely. To encompass this whole collection of analytical tools, machine learning techniques, the stuff that's been optimizing factories, predicting failures, checking quality for ages. The article has that great line. This was happening long before anyone asked a chatbot to write a poem. They were predicting part failures, optimizing material flow, analyzing sensor data for tiny anomalies.
So the amnesia is dangerous because we might throw out the baby with the bathwater.
Yeah.
Discard proven tools.
Exactly. It leads to a really narrow view. You risk ditching effective, reliable solutions for something new, maybe misunderstood, potentially misapplied, just because it's hyped. It's like forgetting basic engineering principles just because you got a fancy new calculator doesn't make sense.
Which leads perfectly to that orchestra analogy the author uses. I love this. The conversation shouldn't be about replacing everything. Instead, it should be about adding a powerful new instrument to an already well-stocked orchestra. Why is seeing it as augmentation, not replacement, so vital for industrial leaders making decisions right now?
It's vital because it frames the strategy correctly. Think about an orchestra. Each instrument has a role, a sound, a purpose. A flute can't do what a tuba does. You need them all working together for the full effect. Generative AI is like that new, maybe very versatile instrument, but it can't play every part.
So it's not about finding the one super instrument.
No, not at all. And the source points to survey data confirming this. The really forward-thinking companies, they get it. They know they need specific AI tools and data science techniques for each specific use case. It's strategic augmentation. Use generative AI where it shines creation, conversation, interfacing. But keep relying on and improving the proven tools for prediction, optimization, quality control, tasks they're built for.
And if you don't have that nuanced view,
You risk major missteps, wasting resources on the wrong applications, missing opportunities with existing tech, maybe even compromising safety or quality. Like the author says, success means understanding the entire toolbox, not just the shiniest new hammer. You need to be the conductor, knowing when to use each section.
okay, let's open up that toolbox then. Section 2, decoding the industrial AI toolbox. If it's an orchestra, what are the key instruments? The article starts with the workhorse, predictive machine learning ML. What makes ML so fundamental, so reliable in these tough industrial environments?
Predictive ML really is the foundation. Its power comes from finding these deep, often hidden patterns and massive amounts of data patterns humans just couldn't spot. We're talking algorithms like random forest, gradient boosting.
Could you give us a quick sense of what those do, in simple terms?
Sure. Random forest, think of it like building lots of decision trees like flowcharts and then averaging their predictions. It's robust, like getting opinions from a diverse expert panel. Gradient boosting builds models one after another, each one trying to fix the mistakes of the last, so it gets incredibly precise. And both are fantastic at handling structured numerical data, sensor readings, operational logs, temperature, pressure, all that stuff factories generate constantly.
And the goal is prediction.
Exactly. Forecasting future events based on past patterns. The article gives great examples. Predictive maintenance or PDM. Using ML to predict when a machine might fail before it actually does. So you schedule maintenance smartly, avoid costly breakdowns.
Moving from reactive to proactive.
Precisely. Then there's anomaly detection. ML models watch processes constantly, looking for tiny deviations from normal, a slight temperature change, an odd vibration. Early warnings for quality issues or safety problems. And demand forecasting predicting future needs to optimize supply chains, manage inventory better, reduce waste. Hugely valuable. The key things here are precision and, well, it's pretty deterministic, reliable calculated outcomes based on data.
That deterministic nature sounds crucial for industry, where things need to be predictable, right? Especially compared to newer, more probabilistic AI.
Absolutely critical. That reliability stems from a few things. One, the precision we mentioned. These models can be highly accurate when trained well. They don't just vaguely suggest a problem. They can often pinpoint when or where. Actionable intelligence. Two, they are largely deterministic. Same input data, same output, every time. That consistency is vital for control systems, for monitoring. You need predictable, verifiable behavior for safety and stability.
No room for creative interpretations when a critical system is involved.
None. It's about calculation, not creativity. And third, the proven track record. These aren't brand new ideas. They've been used, refined, validated in real factories, real plants for years. There's a history of success, which builds trust. You rely on them for critical decisions because they've earned it.
Okay, so ML predicts what might happen. What about figuring out the absolute best course of action? That sounds like optimization algorithms. The article calls them mathematical engines for solving puzzles. Tell us about their role.
Yeah, if ML gives you foresight, optimization gives you the optimal plan. They are like mathematical engines built to solve incredibly complex scheduling, logistics, or resource allocation puzzles. Industry is always about maximizing output, minimizing cost, improving efficiency, all under constraints, time, budget, materials, whatever.
Finding the best path through all those trade-offs.
Exactly. And the techniques range from classics like linear programming, great for problems where the relationships are, well, linear, like optimizing a simple budget allocation, to more modern methods like genetic algorithms. These are fascinating. They mimic evolution, generate solutions, test them, breed the best ones, add mutations, finding really good answers for super complex, nonlinear problems.
Wow. So what kind of industrial puzzles do they solve?
The source gives great examples, determining the most efficient production sequence, the best order to make things to maximize throughput and minimize downtime, finding the most profitable product mix based on current costs, demand, and resources, strategic stuff, and calculating the lowest cost transportation routes, absolutely crucial for supply chains, cutting fuel costs, emissions, ensuring timely deliveries. Basically, anywhere you have tons of possibilities and need the mathematically best answer, these algorithms are working behind the scenes.
Okay, moving from numbers and logic to seeing, computer vision. It sounds futuristic, but the article positions it as a core industrial tool. How does it actually work on the factory floor, and what problems does it solve that humans maybe can't or can't do as well?
It does sound sci-fi, but it's very real and incredibly practical now. It mainly uses deep learning, especially convolutional neural networks, or CNNs. Think of CNNs as systems loosely inspired by how our visual cortex works. They learn to recognize patterns in images by breaking them down into features, edges, textures, shapes.
Like teaching a machine to see by showing it millions of examples.
Kind of, yeah. It learns to identify objects or defects. The article calls it the tireless eye on the production line. And it's not just watching, it's analyzing and enabling automation. A huge application is quality inspection, doing it with superhuman accuracy. Imagine inspecting tiny electronics for microscopic flaws, or checking labels or paint finishes. Thousands per hour.
Something a person would struggle with over a long shift.
Exactly. Fatigue, inconsistency. Computer vision systems do it 24/7 consistently. Huge impact on quality. They also monitor for safety compliance. Are workers wearing hard hats? Is anyone in a restricted zone? Real-time alerts. And they do high-precision metrology, measuring parts with incredible accuracy to ensure they meet specs.
What's the main advantage driving its adoption?
Accuracy and consistency are key, but the big one is speed. As the article says, all at speeds no human could match. This allows for 100% inspection on fast lines, which is often impossible manually, drives quality and efficiency.
Incredible. Okay, one more tool from the pre-generative AI era. Traditional natural language processing, NLP. Before chatbots were writing poems, what was NLP doing with all the text generated in industry, the unstructured stuff?
That's a great point, because text is everywhere in industry too, not just numbers and images. Traditional NLP was already tackling this unstructured data challenge years ago. Think about all the text. Maintenance logs, technician notes, often handwritten or typed informally, incident reports describing safety issues or equipment problems, operator notes jotted down during shifts, customer feedback, manuals, specs.
A sea of documents, like the article says, hard to analyze systematically.
Exactly. So traditional NLP's job was to make sense of it, parse these documents to identify recurring problems. Maybe the same part keeps failing according to maintenance logs across different sites. Or uncover hidden trends, like are safety incidents clustered on a certain shift or related to a new material? It could analyze sentiment and feedback. The goal was extracting actionable insights that were otherwise buried, insights you'd miss without painstaking manual reading. It turned unstructured words into structured data or identified key themes, helping companies fix problems, improve processes, enhance safety, all using the text narrative of their operations long before generative models became famous.
Okay, so we have this established toolbox. Predictive ML, optimization, computer vision, traditional NLP, each a specialist. Now, section 3. Enter generative AI. The article is emphatic. It is not a replacement. It is a fundamentally different type of tool with its own unique strengths. What are those unique strengths? How does it differ fundamentally from the tools we just discussed?
Yeah, this distinction is absolutely key. Generative AI's unique power is primarily in creation and conversation. That's its lane. Unlike predictive ML finding patterns to forecast or optimization finding the best constrained solution, generative AI produces new stuff. Or it talks. It's about generating novel content, not analyzing existing data in the same way.
So what kind of tasks does it excel at in industry, according to the source?
The article highlights a few key areas. It's brilliant for summarizing complex reports, taking dense technical docs, long incident reports, research papers, and boiling them down to understandable summaries. Huge time saver.
I can see the value there immediately.
Absolutely. It also excels at generating code, speeding up software development, automating some coding tasks, maybe helping engineers prototype quickly, and critically, acting as a natural language interface to other systems. This is a big one.
Like talking to your factory systems in plain English.
Exactly. Imagine asking your ERP system, what's the stock level of part X? Or asking for the maintenance schedule for machine Y just by speaking or typing normally. Or a chatbot guiding a technician through troubleshooting, pulling info from manuals dynamically. It makes complex interactions intuitive. Its power is in understanding and generating human-like language and content on demand, creation and communication.
So, to boil it down, it's about what it creates and how it communicates, much more than analyzing numerical patterns for prediction or optimizing complex processes based on math.
You nailed it. That's the core difference. Predictive ML deals with structured data, deterministic outcomes. Optimization finds mathematically best paths. Generative AI is about fluency, creativity, interaction. It's inherently probabilistic, predicting the next likely word, for instance. And understanding that difference is crucial because forcing it into roles requiring deterministic precision, well, that's where things go wrong. It's a great instrument, but for specific kinds of music.
Which brings us right to the danger zone. The article gives a stark warning. Applying the wrong tool can be ineffective at best and dangerous at worst. It seems obvious, but height can cloud judgment. Can you give us some clear examples, maybe from the source, of how misapplying AI could be genuinely dangerous in industry?
Right, this right tool for the right job mantra isn't just good advice. It's fundamental for safety and operational integrity in this field. The article uses really clear, almost blunt examples. It says, you would not use a computer vision system to schedule your production line.
Because it sees things, it doesn't understand logistics.
Precisely. It has zero capability to understand resource constraints, machine capacity, demand forecasts, all essential for scheduling. It's like using a microscope to hammer a nail, completely the wrong function. Similarly, nor would you use a mathematical optimizer to analyze a maintenance log. An optimizer solves quantitative problems, best routes, best mix. It can't read text, understand nuance in technician notes, or spot qualitative patterns. That's a job for NLP or maybe Gen AI. Using the wrong tool is just fundamentally mismatched. Ineffective, waste of time.
Okay, those are clearly ineffective. But what about the dangerous part? Especially with the new kid on the block, generative AI. The article specifically asks why using a general-purpose LLM to predict a precise failure point on a critical asset is such a misuse. Why is that dangerous?
This hits the absolute core of the risk. General-purpose LLMs, powerful as they are for text and chat, operate based on statistical probability. They predict the next likely word based on patterns in their training data. They don't perform deterministic, physics-based calculations. They don't understand the underlying mechanics or engineering principles of a critical pump or turbine in a fundamental way.
So they're essentially making educated guesses, very sophisticated ones, but still guesses.
In a way, yes. Extremely sophisticated pattern matching and generation. But predicting a critical failure point for process control or asset health requires absolute precision, certainty, determinism, high-stakes calculations. A probabilistic best guess from an LLM is completely unacceptable here. The potential consequences are too severe. And that's where the article's chilling contrast comes in. A hallucinated answer from a chatbot is an annoyance. A hallucinated prediction for a critical pump failure could be a catastrophe.
That really puts it into perspective, an annoyance versus a potential disaster.
Exactly. A wrong prediction for that pump could mean massive downtime, huge financial losses, serious safety risks, environmental damage. The stakes are incredibly high. For those jobs, you need the tools designed for precision and determinism. Predictive ML trained on specific operational data, maybe physics-based models, digital twins, not a general-purpose language model. Understanding this distinction is non-negotiable.
Okay, so given these distinct strengths, weaknesses, and potential dangers, the path forward isn't about picking a winner, is it? It sounds like integration is key. Where does the real power lie?
You've got it. The real leverage, the most sophisticated approach, is what the article calls a blended approach. The most mature companies, the ones really getting value, they understand this. No single tool does it all. So they're building the teams and, crucially, the technology infrastructure the article mentions, industrial data fabrics, which we've talked about before, that let them deploy the right tool for the right job seamlessly.
Can you remind us briefly what an industrial data fabric enables here?
Sure. Think of it as the connective tissue. It's an architecture that lets you gather, manage, and access data from all sorts of industrial sources, sensors, systems, logs in a unified way. It breaks down data silos, ensures quality, and makes the data readily available. This is what allows different AI tools, different instruments in our orchestra, to work together effectively. It enables that seamless deployment and orchestration of the right capability for each part of a problem.
Got it. The fabric connects the instruments. Can you give us that concrete example from the article? How does this blended approach actually look in action?
Yeah, the article gives a really practical, compelling example. Let's stick with that critical pump scenario. An anomaly occurs. Step 1. They might use a classic machine learning model to detect an anomaly. This ML model, trained on that specific pumps data, vibrations, temperature, etc., flags a deviation from normal. Precise, reliable detection. That's its job.
Okay, ML spots the problem. Then what?
Then comes the blend. The operator needs to know what to do, right? So they then use a generative AI model to summarize the findings alongside relevant troubleshooting steps from the maintenance manual for the operator. See the difference? The generative AI isn't predicting the failure. The ML did the deterministic detection. The generative AI interprets the ML output, writes a clear summary in plain English, finds the exact right troubleshooting steps from potentially huge manuals, and presents it all clearly to the operator, maybe even conversationally.
Wow. So ML detects, Gen AI explains and guides. They work together.
Perfectly put. ML provides the precision, generative AI provides the intelligent interface and actionable guidance. Each plays to its strength. That's the blended approach in action. It creates a solution that's faster, more effective, more user-friendly than either tool could achieve alone, reduces downtime, improves response. That's the power of synergy.
So it's clear generative AI definitely has its place. It's not just hype. The article says it's rightfully earned its place in the toolbox, despite the limitations we discussed.
Absolutely earned it. Because it has opened doors to new possibilities, and it's democratizing access to technology. It makes complex info easier to grasp, speeds up content creation like manuals or reports, enables those intuitive interfaces. More people across the organization can leverage AI now, even without deep coding skills.
So it lowers the barrier to entry in some ways.
In many ways, yes. Think of supervisors generating reports easily, or technicians getting instant guidance. It accelerates tasks involving language and summarization, freeing up people for harder problems. But, and this is the article's drumbeat, it is one tool among many. Back to the orchestra. It's a powerful new violin or trumpet, maybe enhancing the symphony, adding new possibilities, but it doesn't replace the strings, the percussion, the brass section. Its value comes from being integrated smartly into the whole ensemble. And as Colin Masson hints, this is an ongoing story. He plans to talk about AI agents acting as the master conductor in the future, orchestrating all these tools, so we're still learning how to best conduct this orchestra.
What a fascinating journey through the industrial AI landscape. It's so clear that yes, generative AI is exciting, but the real magic, the real advantage, comes from understanding that whole orchestra. For you listening, whether you're prepping for a meeting, trying to get up to speed, or just curious, the big takeaway seems obvious. Quick knowledge is good, but thorough understanding of the full picture is better. Seeing all the tools is key.
Exactly right. Knowledge is powerful, but only when it's understood in context and applied strategically. Critical thinking is paramount, especially with new tech hype. We didn't just talk about what these tools are, but why using the right one matters so much for efficiency, for results, and definitely for safety. It's about building an intelligent industrial future thoughtfully.
Which leads us to a final thought for you to chew on. Given this incredible potential for value, but also the risk of serious error if we misuse these tools, how can organizations effectively build true AI literacy at every level? Not just adopting the tech, but ensuring everyone, from the boardroom strategists to the operators on the floor, understands enough to use this AI orchestra wisely and safely. What do you see as the biggest challenge or the biggest opportunity in getting that right tool for the right job approach embedded everywhere? Something to think about. That's our deep dive for today. Huge thanks for joining us as we explored the insights from Colin Masson, Research Director for Industrial AI at ARC Advisory Group. Until next time.